In this video, we're going to look at arithmetic sequences. And arithmetic sequences are a list of values, usually integer numbers. And the arithmetic sequence is a list of numbers that is generated by either adding or subtracting the same value over and over again to create new values. And arithmetic sequences always have an initial value that is a T1, if you like, or the first term. And this is sometimes referred to as the A value. Okay? Now, arithmetic sequences also have what is referred to as a common difference. And this common difference is the value that is added, if it's positive, or subtracted, if it's negative, to create the next number and the next number and the next number. Okay? So, for example, in this sequence here, we are told that the first term equals 3. Okay, we're also told that the common difference is positive 5, which means that if I take 3 and I add 5, I will get the second term, which in this case turns out to be 8. Okay, well, if I repeat that process, because remember we said this is the common difference, so that is each one of these terms is generated by adding the same amount to get to the next term. T3 turns out to be 13. Well, we can start doing these in our head now because we can say that T14 is going to be another 5, or T4 rather. T5, add another 5. T6, well, do it again. T7, T8, T9, and finally, why don't we stop at T10? Okay, so this question asked us if we could find the 5th and the 10th term. And sure enough, there's the 5th, 23, and there's the 10th, 48. So we can find these terms by applying the common difference and writing out a sequence of terms, and we can just find each term that we want when we arrive at it. Now, well, it wasn't too bad here because we had the 5th term and the 10th term. But what if they asked us to go ahead and solve for the 100th term or the 500th term? Well, there's no way that I'm going to sit and list all of those values one after another. There must be an easier way, and there certainly is an easier way, and it is called the general term for an arithmetic sequence. Okay, so this is the general term. And what does that mean? Well, it means that we can use this little formula to find out any term in the sequence, and we can go there directly. We don't need to list all the ones previous to that term in order to find it. So let's try and use the general term to go directly to the 5th and the 10th term and see if we get the same values. So here's how it works. It says Tn, so whatever term we're looking for, we will substitute in for n. So this would be T5 or T10. Now, it uses a value a. Remember I said that was the common, or the T1 value, the starting value in the sequence. And then n minus 1 times d, which is the common difference. Okay, so how would we write that for the 5th term? Well, we would just say that the 5th term is equal to whatever the a value is, and then we would add to that n minus 1. Okay, so here n is 5, so we're going to say n minus 1, and then we're going to multiply that by the common difference d. So let's go ahead and substitute in values. So the 5th term is equal to a, or T1, is 3, plus n, well, I'm looking for the 5th term, so n is 5, minus 1, and the common difference is 5. Careful with bedmass rules. We're going to add 4 times 5, okay? And 3 plus 20 23. So T5 is equal to 23, and sure enough, it is. And that kind of makes sense. If you look at the general term, we can see that we added 4 common differences to get value 3, the first initial term, up to term 5. And that is what happened. If we start here, we add 1, 2, 3, 4 common differences to get up to the 5th term. So that general term kind of makes sense. Let's apply the general term and go directly to the 10th term. So in this case, T10 is going to equal, and I'll just put in the values right away here. We're starting at 3 plus, this will be 10 minus 1 times the common difference 5. 3 plus 9 times 5. BEDMAS says take care of that multiplication first. So 3 plus 45, and that is going to be 48. And that matches as well. Okay, so there is an arithmetic sequence, and that is the general term equation, and we can use that little equation or little formula to go directly to any term in the sequence. We just sub in the values for A, the first term, N, the term we're looking for, and D, the common difference. How big are the steps to transition in between the terms? Okay. Let's take a look at a question that's a little more challenging than this one. Okay, in this question, we're asked to find the first term of the arithmetic sequence with T17 equals 3 and T22 equals 53. All right, so how do we do that? Well, we could think about applying the same kind of reasoning that we did in the first question, and that is, why don't we start at 17 and just sort of walk backwards? Go back to the 16th term, back to the 15th, back to the 14th, and keep going all the way back to the first term. And that would be fine. The only trouble is I don't know how big the steps need to be in between. I don't know what the common difference is. So in this question, regardless of how I want to solve it, whether I want to try and use the general term or whether I'm just going to list the terms, I need to find the common difference. So the first thing we're going to do is we are going to solve for the common difference. All right. And that has to happen first. So how do we do that? Well, let's see what we're given initially. We are told that we have T17 equals 3, and we're also told T22, the 22nd term, equals 53. So if we just sort of eyeball this and look at it for just a moment, we can see that to go from 17 to 22, we have 5 steps. Okay? So that is 5 common differences were added. All right, well, let's look at the top. From 3 to 53 was an increase of 50. So what does that tell us? Well, we can solve for D directly then. We can say, look, the amount for one step, that is the common difference, is going to be equal to the total distance I traveled. So in this case, it was the 50. And if I divide that by the number of steps I took, in this case 5, I can figure out that the common difference is 10. Okay? So that's one way to find the common difference. Well, how else can you find it? Well, I can solve it algebraically. And algebraically just means using a formula, and then we're going to go ahead and isolate the variable to get the answer. So what formula do we use? Well, we're going to use the general term. And how do we use it? Well, we're going to write the general term twice. We're going to write it once in terms of T17 and once in terms of T22. So let's write out the general term for T17. So we're told that T17 equals 3. Okay, so 3 equals A, we don't know what A is yet, plus, and if 17 is the value of N, then n minus 1 is 16. So this is going to be 16 times d. Okay? Now, the other equation is going to be for t22. In this case, it will be 53 equals a plus and 21d, because n is 22, so n minus 1 is 21. Now, what do we do with these two equations? Well, here's what I want to do. Let's just subtract them, because if I subtract them, then we will subtract away the a's, and they will vanish. So 3 subtract 53 is negative 50. The a minus a is 0, and 16d minus 21d is negative 5d. Isolating for d, we'll just move the negative 5 to the other side. We'll have negative 5 at the bottom there, and that equals d, and sure enough, d is going to equal 10, because negative 50 divided by negative 5 is positive 10. So there we go. Both ways are completely fine for finding the value of d, and once we get that value, we could very quickly check that it works, because we could say, okay, well look, t17, it was 3. Well, that means that if I use my d value, t18 should be 13, 19, 20, 21, and 22, and bingo. Okay, so it does work for starting there. t17 equals 3, and ending at t22 is 53. The common difference of 10 works. So what do we do with that common difference now? Well, we're going to use that common difference to help solve for t1. Okay, now we're asked to find the first term of the arithmetic sequence. So in order to find the first term, we're going to go back and we're going to once again use the general term. And we're going to, once again, look at the information we were given. We were told that t17 equals 3. Let's use that information, put it into the general term, and we're also going to use the fact that we just figured out d was 10. So let's put that all together. So t17 equals 3. So 3 equals a, that's what I'm looking for, I don't know what a is, plus, I do know what n is. N is 17. So 17 minus 1 is what's in the brackets here. And d, I now know from my little work in below here that d is 10. So solving, we get 3 equals a, careful, bedmass, plus 160, 16 times 10, or negative 157 equals a when I move the 160 to the other side. So therefore, the first term is t1 equals negative 157.